Yeah, hi everybody. My name is Ingo Wirth. I'm a project manager at Fraunhofer IFAM, and I'm responsible for the activities of Fraunhofer IFAM in Morpho project. Some words to Fraunhofer IFAM. IFAM means Fraunhofer Institute for Manufacturing Technology and Advanced Materials. IFAM is one of 75 institutes in the Fraunhofer Society, and the Fraunhofer Society is with a research and development volume of nearly 3 billion euro and approximately 30,000 employees, the largest organization for applied research in Europe. Fraunhofer IFAM is located in Bremen. This is the location of the headquarters and also where I work. Furthermore, IFAM has also departments in other cities in Germany, also, for example, in Dresden with main topic powder metallurgy, and also in Stade, where we are working especially for Airbus with carbon fiber materials. And we are also located in Braunschweig for energy storage and systems. And furthermore in Wolfsburg, this is for electromobility. And we have also some activities for maritime technologies, which is located in an island of Helgoland. So at Fraunhofer IFAM, we do applied research in the fields of adhesive bonding technology and surfaces, and also shaping and functional materials. This competence means also that we take a look on the whole process from material to component, and also the development of innovative manufacturing processes. So we coming from the material such as powder or ink, and use this material to generate functions in parts and components. To do this, we use different printing technologies, and I will show this later in some videos, especially what we do in the project Morpho. And by integrating sensors in parts and components, they have new functional activities, so they can measure temperature, they can detect mechanical stresses, or can detect humidity, or also other things that can be included in the parts and components. What is also important is quality assurance and digital transformation. This plays also a central role in the surface technology, and therefore we also work on these processes and concepts to allow process control, and this requirements for quality assurance. This is also very important for the manufacturing processes for stabilizing these processes. And also the composite materials this is a topic which we should take a closer look on, because it is very important to monitor the part and to understand the chemical properties and the structure and the interfaces. And because if there are damages in such a material or defects, this should be monitored. And so we use the sensors to damage the analysis, or we can also make corrosion protection and also surface pre-treatment of the materials. We do, at Fraunhofer IFAM applied research mainly for the field in aviation industry. This is our main business area, but also automotive sector, because in this two business areas there are a lot of parts and components needed with integrated sensors. But we also work in the business area of energy technologies and medical technologies and life science, and also what I mentioned in the introduction, we're working in the field of maritime technologies. Yeah, I would like to add that Fraunhofer IFAM has about 700 employees, and we have a total budget of more than 60 million euro per year. Having a closer look to the activities which we have in the Morpho project. So we work on integrating printed sensors and fiber optical sensors in aircraft engine FOD panels. The background is that there is an increasing demand for structural health monitoring of carbon fiber reinforced composite. And the challenge here is that smart systems should be printed on top of composite materials for lightweight constructions using the technologies we have at IFAM. And this innovative printing technologies allows for the integration of sensors in composite parts and components. For example, we have an example part. This is an FOD panel from the company Safran. And during fabrication, we can integrate these sensors. And these sensors can measure temperature, mechanical stresses, pressure, or also can act as an actuator. And data which are generated during the printing process or using the sensors, they can be used for digitalization purposes of structural health monitoring of the parts and components. The manufacturing process can also be investigated by using sensors and also quality controlled continuously during the production. And this fabrication process is so relatively flexible through the automatization. And also an adaptation can be achieved. And therefore, the aim in the Morpho project is for us at IFAM to develop an innovative process with increasing efficiency and using digital manufacturing and integration of innovative functional materials. So we see how to integrate fiber optical sensors in pre-FOD material, which we see here. This is a carbon fibers, and there is an optical sensor which is integrated in the part. Now we see how printed thermocouples should be deposited on fiber composite material on the samples. First is that we generate the data set, and you see this is here as a part we prepare the thermocouples, and then we use printing process. This is aerosol printing with a small nozzle. And then material is here deposited on the sample, and you can see here that the thermocouples are directly printing on the surface of the material here. Yeah, and yeah, this is two different materials. This is copper nickel thermal element, so that you can directly measure the temperature at locally at the part. Okay, here we see how piezo sensors are printed on the fiber composite material. The composite samples are placed here in the screen printing machine, and then you see here the piezo ceramic material. This is spread over the screen here, and so the material, the sensor material itself is printed on the surface of the samples, and then when it comes out of the machine, you can see the printed piezo structures on the samples, the white ones. You also see an electrode. This is for contacting the piezo material. And after printing, the structures must have a thermal treatment. So we use an oven, and then the structures will have a heat treatment, and then can be used after polarization process as piezo sensors to detect mechanical stresses. Yeah, thank you all for joining this event, the European Researchers Night, for listening to my explanations to the Morpho project. Bye.